Hello, everyone, and welcome to Precalculus. This is section 5.4, Sum and Difference Formulas. So these formulas are a little bit long. You are not required to memorize them, but you are required to know how to use them. So this first question is a little bit archaic, meaning it's not something that you would be doing today because you have a calculator. You would just type it in. But it will allow me to show you how this formula works so that when I do harder problems, you'll already have an understanding of it. So I'm going to break cosine of 75, which you only know how to solve on a calculator, and I'm going to break it down into cosine of 30 plus 45, which are two angles that you are familiar with. Now that I have it written like that, let's consider that alpha and consider that beta. I can rewrite this using the formula right here as cosine of 30 cosine of 45 minus sine of 30 sine of 45. And then that becomes cosine of 30 is the square root of 3 over 2. Cosine of 45 is the square root of 2 over 2. Sine of 30 is 1/2, and sine of 45 is the square root of 2 over 2. That gives me the square root of 6 over 4 minus the square root of 2 over 4, which, because they have a common denominator, you could take it one more step, but please do not write the square root of 4. You cannot combine unlike radicals, so you would have to stop there. So this is how somebody would have done a problem if they could make this into angles that they already knew, some kind of sum or difference of known angles. We'll do another one, but this time in radians. So sine of pi 12ths. This is significantly harder because with 75, you could look at it and think, well, I mean, you really only know 30, 45, 60. So finding a combination that works was easy. Much harder here, but this is how we're going to do it. You're familiar with pi 6, pi 4ths, and pi 3rds. I guess you could say also pi halves. Well, this is 2/12. This is 3/12, 4/12, and 6/12. Now that I've made them all into 12ths, now can you think of a combination that would give you just pi 12ths? You actually have several choices. You could do 3 pi 12ths minus 2 pi 12ths, or 4 pi 12ths minus 3 pi 12ths. Either one. So I'm going to choose, I really have no preference. Actually, that's not true. I'm going to choose the pi 6. So I don't know, I just like sine of pi 6 better. So sine of 3 pi 12ths minus 2 pi 12ths, which of course helps me see that that's equal to 1 pi 12th, but it's not convenient for doing anything else. So I'm going to change it to sine of pi 4ths minus pi 6. Now I'm going to go back and look at my formula. Now I'm going to choose this one, which is going to go sine, cosine, cosine, sine. So sine of pi 4ths, cosine of pi 6, minus cosine of pi 4ths, sine of pi 6. Sine of pi 4ths is the square root of 2 over 2. Cosine of pi 6 is the square root of 3 over 2. Cosine of pi 4ths is the square root of 2 over 2. And sine of pi 6 is 1/2. That gives us the square root of 6 over 4 minus the square root of 2 over 4, which since they have a common denominator, you want to write them together. You could write it as this. And somebody might be thinking, hey, didn't we just get that answer a minute ago? How many problems could there be that have that exact same answer? Well, cosine of 75 is related to sine of pi 12ths. So if you have pi 12th, that's the same as 15 degrees. So in a triangle, if this is 15 degrees, triangle clearly not drawn to scale, and there's 75 degrees, then if you have x, y, and h, Sine of 15 degrees is y over h. But cosine of 75 degrees is also y over h. And that's why they had the same answer. Because two complementary angles where you find sine for one and cosine for the other will have the same answer. That's why they're called sine and cosine, because they are complementary. Just as a little fun fact there. Okay, next one. Find the exact value of sine of alpha plus beta, and then they give you some information. These are very challenging for students, but I'm going to lay it out. I'm going to give you steps, so you should be able to do it. First step, write the formula. People really don't like to do this step. But if you write the formula, everything else will be easier. So sine of alpha plus beta is going to be sine alpha cosine of beta plus cosine of alpha sine of beta. Step 2, draw two triangles. So I have an alpha triangle, and they told me that sine of alpha is square root of 3 opposite over hypotenuse 2, which means that if you do Pythagorean theorem, this must be a 1. They also told me that alpha is between pi halves, which is here, and pi, which is here. So this was their way of saying quadrant 2. That's going to make a difference. We always have to be thinking about the forecast. And then my other triangle, you might want to try and draw it on your own, is the beta triangle. They told me that tangent of beta is negative 15 over 8. So tangent is opposite over adjacent. And this is a Pythagorean triple that we don't use as often, but it's 8, 15 if you use the Pythagorean theorem, 17. They told me that this one is between 3 pi halves and 2 pi. So I'm in quadrant 4. Now, some people would actually draw this in quadrant 4. That's fantastic. I don't draw it in quadrant 4. I just know that that's going to affect my forecast. So step 3, fill in the formula. So sine of alpha is the square root of 3 over 2. Remember that I'm in quadrant 2, so sine is positive. Cosine of beta is 8 over 17. I'm in quadrant 4, and cosine is positive there. So if you forgot those, you would have gotten lucky because they're already positive. Cosine of alpha is 1 over 2, but I'm in quadrant 2, so it's negative. And then sine of beta is opposite over hypotenuse, 15 over 17, but because it's in quadrant 4, it's negative. And again, if you had forgotten forecast completely, you actually would have gotten this one right, because negative times negative would make it positive. But because I check your work, you still would have gotten it wrong. This gives me 8 square roots of 3 over 54 plus 15 over 54, which you could box that answer, or since it does have a common denominator, you could write it as 8 square roots of 3 plus 15 over 54. Either one. Okay. All right. Next, we're going to do a little proof. This is like solving an identity, but they're really nice in this section because it really, when it says show, they really just mean use the formula. So these are going to be your favorite kind of proofs to do. So sine of pi cosine theta plus cosine pi sine of theta. Sine of pi is 0, and cosine of pi is negative 1. This cancels, and I just get negative sine of theta. If you were making a line, then you would have just shown that they are equal. So as proofs go, these are really pretty great. Number 5, find the exact value of sine of 42 cosine of 12 minus cosine of 42 sine of 12. I'll have to add this here without your calculator. So when it says exact value, your calculator can't give you the exact value. When you have, say, square root of 3 over 2, your calculator is going to give you 0.866, blah, blah, blah. But it's rounded it. This is the exact value. So at first glance, you might think, how am I supposed to do that? This is just doing the formula backwards. So if you go back to the first page and look at all the formulas, see which one it matches, you will see that the sine, cosine, cosine, sine is the sine of alpha with beta. And how are they connected? Well, when there's a minus there, there's a minus here. It's the opposite for cosine. So this just becomes sine of 30. And what is sine of 30? Sine of 30 is 1/2. There's a little stray mark there I'm going to erase because it's not negative. Okay, number 6. So this one gets a lot trickier. So when you see arctan 1, you need to be thinking to yourself that this is the ratio and that arctan 1 is equal to the angle. It's kind of like saying, okay, I know the answer is 1, so what is the angle that goes with that? Now, you might know that it's pi fourths. Don't even try to go there because we're going to do it a different way. And that won't work when you have an x there. But keep in mind that this represents an angle, and this represents an angle. And if you think of that way, then you will do it the exact same steps we just used. Step 1, this is cosine of alpha plus beta. So write out the formula. It's going to be cosine, cosine, minus, for cosine it's opposite, sine, sine. Step 2, remember, is to draw the triangles. So for my alpha triangle, it says that tangent is 1. Well, since tangent is opposite over adjacent, that's what it would look like. And then if you did the Pythagorean theorem, you would get the square root of 2 for the last side. In your beta triangle, it says that arc cosine of x is equal to the beta. So cosine is, think of it as x over 1, adjacent over hypotenuse. Now when you do the Pythagorean theorem, x squared plus, let's just call this m squared is equal to 1 squared. So m squared is equal to 1 minus x squared. M is equal to the square root of 1 minus x squared. So I just used that m temporarily. This side is 1 minus x squared. So now you can fill it in. Step 3, fill it in. So cosine of alpha, look at the alpha triangle. Cosine of alpha is 1 over the square root of 2. Cosine of the beta triangle is x over 1. Sine in the alpha triangle, so sine of alpha is opposite over hypotenuse. In sine of beta, whatever angle this is, the sine of it is opposite over hypotenuse. Square root of 1 minus x squared over 1, which simplifies to x minus the square root of 1 minus x squared, and they both have the same denominator, which is the square root of 2. What are the key to doing this problem? The steps. You have to do the steps. You have to write out the formula so you can fill it in for step 3. You have to make your alpha and beta triangles and then fill it in. Okay, we only have one left, but this is a really hard one. So sine of x plus pi fourths is going to be, using the formula, sine of x cosine of pi fourths plus cosine of x sine of pi fourths. And then sine of x minus pi fourths is going to be sine of x cosine of pi fourths minus cosine of x sine of pi fourths. And all that is going to be equal to 1. Now, fortunately, something good does happen right away. These two are the same, so I can cancel them. And then these two are also the same. So now I can say I have 2 sine x cosine of pi fourths is equal to 1. I can replace the cosine of pi fourths with the square root of 2 over 2. Now these three are being multiplied. So if you think about fractions, whole numbers times fractions, you can multiply straight across the top and straight across the bottom, which means my 2's are going to cancel. And now I have square root of 2 times sine of x is equal to 1. I divide both sides by the square root of 2, and I get 1 over the square root of 2, which may not be something you recognize just yet, but as soon as you rationalize the denominator, hopefully you'll see that it's the square root of 2 over 2. Oh, hold on, I just found a little mistake here. This is equal to -1. So before we keep going, and why does that make such a big difference? Because my next step was to say, when is x equal to the square root of 2 over 2? It is at pi fourths, but because it's negative square root of 2 over 2, I have to use my forecast. And where is sine negative? In quadrants 3 and 4. So pi fourths is just a reference angle. The actual answers are going to be 5 pi fourths and 7 pi fourths. That's where sine is equal to negative square root of 2 over 2. All right, that's it for section 5.4. Have a great day.